Students, let's start with chapter number 2, motion. In this chapter, you will learn about the definition of motion, identify object in motion and at rest, type of motion with example from daily life, define uniform and non-uniform motion with example from daily life, concept of speed, average speed, calculate average speed of object, define weight, relate weight of an object with its mass. So let's see the definition of motion. An object is said to be in motion if its position changes with time. Let's see and understand it with some example. Now, let us understand the examples of motion. We all know what this line means. Its ups and downs reflect the situation of our life. The blood vessels. The blood vessels are continuously flowing in arteries and veins, supplying nutrients to our body with respect to time. The earth is spinning on its own axis, which causes day and night. Do you know what common among these events? Yes, they are in movement or in motion. What would happen if the aspect of movement was removed from this event? If things stop moving, you can't even imagine the consequences that it might bring to us. And even if we are facing failure in life, we need to learn and move forward. Thus, examples tell us that movement is life. The different type of motions are studied in physics. To better understand, let's look at the park. We see various activities happening over here, like walking, running, playing, cycling, etc. What are these people doing? And what is common in these events? Yes, they are moving or they are said to be in motion. Motion. Now, time and tide waits for none. The part of the phrase that tells waits for none, that means we have to move simply with time. Thus, we can say that movement with time is called motion. If we will compare that the phrase is compared to ourselves with life, thus we can say that motion is compared to or related to something. Now, as you can see, the car is moving, so we can say that it is in motion, and the person sitting not moving, it is said to be not in motion or stationary. But are they really stationary? Thus, this stationary objects are along with us on Earth. And as we all know that the Earth is not moving only on its axis but also revolving around the Sun. So thus, we can say that Earth is moving 24 into 7. So technically, all the objects on Earth, example you, me, all the stationary objects are in motion. So even if the stationary objects are said to be in motion, why do things appear stationary to us? It is because when we are seeing things from our own perspective, we see that the object is stationary because as we are also seeing it from the earth, so it appears to be in stationary. But if we are looking from this space and seeing the same object, then from our own perspective, the object is seems to be in a motion. This relative position of an object is called inertial frame of reference. By this, we came to know that the object that seems to be in motion or at rest explains that motion is relative. Now, these concepts are not followed only on Earth but also in our solar system and galaxy of space. Let's understand with the situation. Imagine you and your friend are sitting in the car, but if you will notice that your friend, with respect to yourself, is in stationary, but everything outside the car window is moving behind, like the man sitting. If we are seeing from the man's aspect, it's the car that is moving. Now, Now we can conclude that motion is relative. Now let's be the observant. Though the objects in the park are in motion directly or indirectly, we all notice that all the objects in the park are not same types of motion. Now let us understand with this situation. A person is jogging on the straight road. This type of motion which occur along a straight line is called rectilinear motion. Example, light from the bulb, star or solar system always travel along the straight line and hence is the good example of rectilinear motion. Now we see some children are playing with a ball. We can notice that ball does not travel along the straight line but rather takes a curved path. So this type of motion is called curvilinear motion. Now let us see few more examples of curvilinear motion. The game of cricket is the good example of curvilinear motion. If we hit a six, we notice that a ball follow a curved path. So now we have all understood that what rectilinear motion and curvilinear motion is. Now let's see the scenario of the race. Here the kids are running in a race and at the end we can see that there is a tie in three kids. It is because all the three kids took the same amount of time to cover the same distance in the race. Thus, we can conclude when a body travels a same distance in equal amount of time, it is called the translatory motion. So now we have understood three kinds of motion. Now, while looking at the car or the cycle, we can see that the tires are moving and their motion is called rotatory motion or it's a circular motion. Other examples of circular motion are also merry-go-round and spinning top, and you can see that they are moving around axis. Now, if we can see the bunch of kids swinging around from the center in to and fro motion, this repetition of motion is called oscillatory motion. Where else it can be seen? It can be seen in the pendulum of a clock. Now, if the rate of oscillation increases rapidly, now it is called vibratory motion. For example, it guitar, violin, drum, etc. are the few examples of vibratory motion. Periodic motion. If a body repeats its motion after a regular interval of time, it is called as periodic motion. For example, clock, Earth revolving around the Sun, and Halley's Comet, which is seen after 75 years. Periodic motion can also be called as uniform motion because the movement is done in equal interval of time with constant speed. For example, if a man covers a distance of 10 meter for every minute, then at the end of 10 minutes he would have reached a distance of 100 meter. This can be applied on other type of motion as well. For example, if this type of motion is carried out in a circular path, then it is called as uniform motion. But what if the man is not covering the constant length in equal interval of time? So, to cover a distance, he has to walk sometimes slowly or sometime fast. And this is known as non-uniform motion. Non-uniform circular motion can also be applied on other motion. For example, if this is carried around a circular path, then this is called as non-uniform circular motion. Now student, let's see what we have learned in this lesson. The importance of motion in our life. The motion is relative with respect to the object and the types of motion. With this, I would like to end. Thank you.